In this video, you will learn about statistical measures. Now, as we begin our study of statistics, there are many different terms that you need to be aware of. So the first set of terms are population versus a sample. A population, by definition, is a set of all the similar items or events which is of interest for some question or experiment. So the key word here is all. Okay, set of all the similar items. Whereas a sample is a portion of a population. All right, so population is the entire group, whereas a sample is a portion of that group. So here are some examples where you need to determine if we are dealing with a population or a sample. Here, example 1, we are looking at every third US president to collect data. So notice this is not every president. This is just every third president. So this is a sample or a portion of the entire population. Now if you were to look at every single president, that would be a population because you're dealing with every president. Now what if you're looking at every current soccer player? This would be a population because we see the word every. We are dealing with every or all the current soccer players, so that is a population. If you're looking at half of the current soccer players, that would be a sample because it is a portion of the entire population. Next we have the terms statistic versus parameter. A statistic, by definition, is a measure calculated from a sample of data, whereas a parameter is calculated from an entire population. So statistic corresponds with a sample of data, parameter corresponds with the entire population. And a good way to remember which one is which, notice statistic starts with an S and sample starts with an S. Parameter starts with a P, population also starts with a P. So if you were to determine if we are dealing with a statistic or parameter, here we have an example. The median age of the US presidents when elected is 55.25. Notice we are dealing with all the presidents. So we're dealing with a population. So parameter goes with population. All right, this number is called a parameter because it is dealing with the entire population. Now if you were looking at 15 US presidents and you were to determine the median age when elected is 58, this measurement is found by looking at a sample of presidents. All right, so because we're dealing with a sample of presidents, this measurement is called a statistic. So we have determined the difference between a sample and a population and a statistic versus a parameter. Now to get a sample of something, so let's say a sample of presidents or a sample of soccer players, what are some good practices when choosing a sample? Well, here are some considerations for choosing a good sample. 1, make sure your sample size is large enough. Okay, if you only take a sample of 1 or 2 things or 1 or 2 people, the information that you gather is not going to be maybe the best. All right, if you take a sample of, let's say, 100 or 1,000 people or more, we get a better idea of whether or not the information we gather is valid. Also realize that if you are taking a survey to collect data, realize that people may lie, especially when you're dealing with weight or height. Okay, many people will lie about their weight or height to make themselves appear better than they actually are. So take that into account. Also, make sure that you choose a good method for collecting the data. So not only do we have, a correct sample size, but also we want to make sure that we have a good way to actually gather the data. And then with the population or with the sample that we are working with, make sure that the sample is representative of the population. So for example, if you are trying to analyze maybe an election and see how people are going to vote, if you sample people from just one community, okay, many times it's not a good representation of the population because that community might all have the same or similar ideas and beliefs. So make sure that the sample you choose, you get a variety of people or things from different places. So it's not all the same type of information that we're gathering, but we're getting it from other places other than just one spot. So make sure that you kind of spread out what data you are collecting. Now with sampling, there are different types of sampling. We have first what is called random. Random sampling is by using something like a random number generator to determine which person to include in the sample. So you're just randomly picking a person or a thing and using that information for your data. Next we have a systematic type of sampling, where we have a systematic approach to gathering data. So maybe, for example, you're choosing every fifth person on your list, or maybe every third person, or some sort of system to not have to collect information from every person or thing from the population, but you can use this to get a good sample or representation of your data. Third, we have convenience sampling. Convenience sampling is doing sampling that is convenient for the person, or collecting data from people that are easy to contact, so from people that are convenient to reach. Another example is cluster sampling. Cluster sampling is including everyone from a particular location or group. All right, so maybe you're collecting information from everyone in third grade, or maybe collecting information from every person playing soccer who is over 30. Okay, you're picking a group or a cluster of people. All right, so here are some examples where you need to determine what type of sampling is being represented. First, we have a teacher collects data from all her students. What type of sampling would this be? Well, this would be probably convenience sampling, because it is convenient for the teacher to just pick students from her class. Right? It's convenient for the teacher to collect this data because she sees her students every day. So this would be convenient for her. So this is a convenience sampling. Second example, we have 1,000 voters are chosen by taking every 10th person that voted. So you're sampling every 10th person. That is a systematic approach to sampling. So this would be your systematic sampling. Third type, here we have 80 people are chosen by assigning everyone a number and then drawing numbers from a basket. All right, this one would be random. You're randomly choosing numbers from a basket. So this would be random sampling. Fourth, we have all the students from the west wing of the school that were chosen. Notice we are choosing a group of students or a cluster of students, all from one particular wing of the school. So this would be cluster sampling. So now we have determined the types of sampling. Now we need to determine the types of statistics. So there are many different types of statistics. Remember, these are measurements that are collected from a sample. All right, so let's say we received information from a sample, and the numbers that we collected, whatever they might refer to, are 5, 10, 8, 8, 7, 12, 14, and 16. Now, before we do anything with determining the statistics or different measurements from this list of numbers, it's always best to rearrange from smallest to biggest number. So here we have arranged from smallest to biggest, 5 to 16. Now, one type of statistic or measurement that we can gather is what is called the range. The range, by definition, is the difference between the largest and the smallest number. So notice the biggest number is 16, the smallest number is 5, so the range would be found by taking 16 minus 5, which is 11. Another type of statistic is what is called the mean. The mean is just another name for average. So if you were to find the average of a list of numbers, you find that by adding all these numbers together, so 5 plus 7 plus 8 plus 8 plus 10 plus 12 plus 14 plus 16, and then divide by the total number of numbers we are adding together. So we're adding 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we divide by 8 after we add them together. If we do that, then on the top we're going to get 12, 20, 28, 38, 50, 64, plus 16 is 80. So we have 80 divided by 8, which would equal 10. So the mean, or the average, of this list of numbers would be 10. Now looking at the same list of numbers, let's try to find the median. So the median, by definition, is the middle number. And it's the middle number after it's arranged from smallest to biggest. Alright, and take note that if there are two numbers in the middle, then you take the average of those two numbers. Now when I find the median, what I do is I work my way from the outside into the inside. So on both the left and the right side, if I go in 1, we now have 7, 14 on the outsides. Let's go in another time, so get rid of the 7 and 14. Do it again with the 8 and the 12. So now we've worked our way in 3 numbers in towards the middle on both sides. And notice we have 8 and 10 here in the center. So here we have 2 numbers in the middle, which means that to find the median, it's not just one middle number, but we have to take the average, in this case, of the 2 middle numbers. So if we average 8 and 10 together, we take 8 plus 10, then divide by 2, that gives me 9 for the median. So the median here is 9. That is my middle number, and in this case it is 2 numbers in the middle, so we take the average. One more type of statistic that we will deal with in this video is what is called the mode. The mode, by definition, is the most frequent number. So the number that you see the most. And take note that if no numbers are used more than once, then there is no mode. And if multiple numbers are used the same amount, then there are multiple modes. So like here, for example, we have the most frequent number that we see is the number 8. So the mode in this case would be 8. Now if you had, let's say, another number at the end, let's say we had another 16 on here, then in this case the mode would be both 8 and it would be 16 as well. So the mode here would have 2 numbers, the 8 and the 16. Alright, so that concludes our lesson for today. We will see you next time.